So good afternoon, everyone. My name is Maurya Hanspal, and in this session, we're going to continue our sessions on the calculation of beta. So in the previous session, we got to know that beta is a measure or a proxy. Proxy is a better word of systematic risk or the undiversifiable risk. And it is found by using the covariance of the security returns and market returns. And these are the returns and not the prices. Okay. So covariance of the security returns and the market returns divided by the variance of the market. Okay. So let's try to do it in the Excel. So like just assume like these are the stock prices at like different time intervals. Okay, the prices of the stock, and this is the value of the market index. By the market rate of returns, we mean that the value of either Nifty or the Sensex. Okay, so these are the stock prices. Maybe like this had been like day 1, day 2, day 3, up till day 8. Okay, for 8 days, like these were the stock prices of a particular stock. We can call it as A, and this for the market index level, be it Nifty or Sensex. Like just took the random numbers for the sake of explanation. Okay, so the first thing that we have to calculate the holding period return. Holding period return is nothing but the percentage return, like between the prices. Okay, yeah, and it's nothing but your final value minus your initial value divided by the initial value. Okay, so just we have to calculate the percentage return as we used to do it in school time. Obviously, like this would be done from day 2, because if we start from day 1, we do not have an initial value before day 1, right? Minus this initial value divided by this initial value. Okay, and the same thing you can like drag it down, and the same thing we can do for the market returns as well. Then the final value minus initial value. So these are in decimal terms. If you want to convert it into percentage, you can just multiply by 100. Okay, so these are the Nifty returns. Okay, so now it says we have to calculate in the formula here. We have to calculate the covariance of the market returns and the security returns in the numerator. So firstly, let's go for the numerator. And I will tell you the shortcut also, in which people don't even have to calculate the covariance and all. So in the numerator, we have to find the covariance. We have a function called covar. Either you can use covar covariance.s or just covar, but use like covariance.s because you're doing for a sample. It says array 1 and array 2. Our array 1 is this return, comma. Our array 2 is this return. And once we close it, we have the value of the numerator. And this is the value of the numerator that we have. We can convert it into percentage. Like let's be here as well only. Okay. This is we got the covariance of these things of the market. And these are returns. So for the denominator part, denominator, you have to find variance, and for the variance of the market only and not the stock, we have a function called var.sample once again, and select the returns of the market and then close the bracket. So like this is the variance of the market that we have. Now the formula for the covariance. What is the formula for the covariance? For the beta. It is the numerator, which is the covariance of the security returns and market returns divided by the variance of the market. Right? We just have to like divide the numerator by the denominator. So here we get your beta. Okay. So like this was a longer way, right? First we calculated the numerator part, that was your covariance of the market returns and security returns. And then we calculated the variance of the market returns. But a shorter way is by using a function called slope. Slope gives you the beta. Slope. So slope, first you can calculate this, the array 1, comma, the returns of array 2, and close it. The answer comes same. Direct way to calculate the beta of the stock or the systematic risk of the stock. So that is one thing. Okay. If you want to calculate the variance or the standard deviation of this returns, again you have the formula of STDEV dot S. You can calculate the standard deviation of these returns as well, right? Again, we people can also calculate the variance of these returns. I'll write here as standard deviation. Similarly, variance can also be founded for them. Function of var dot s. All these returns you can take and close the bracket. You have the var dot s. Similarly, the average return can also be founded out. If you want कि average return कितना है, ये कभी plus रहा है, फिर minus रहा है, then plus हुआ. If you want to find out the average return, again you can find out the average return, which is like by the average function. Again you can go here, control shift down here, and similarly like these things can be founded for your this as well. See, like directly these values were founded out. So people can drag it to the right hand side. And directly the values would come in. Just calculated just for the returns. Like you can like cut the so like directly you got the standard deviation for this, the variance of the and the average return. So see, when you calculate the total of your error term, which was the unsystematic risk, the error term, the unsystematic risk plus your beta, it gives you your total standard deviation, and that is the total risk. Your total risk comprises of the unsystematic risk plus the systematic risk. That is the error term plus the beta. So the standard deviation that we are calculating here now, the standard deviation that we are calculating here is the total risk. So here you got the standard deviation. Here you got the the systematic risk. Then the people can find out the unsystematic risk as well. How? By having this total standard deviation you have in here. And what you can do, you can subtract this amount and you'll get the unsystematic risk. So 0.52. Okay. So this way you can do it. This was the way you can calculate your covariance, variance, standard deviation, your average return as well, beta, and all these things. If you want to calculate the exit return of a stock, like how much return it will give over the benchmark rate, or how much exit return it will give you over the risk-free rate. The risk-free rate is for the government securities. You have the intercept. So if you want to know basically how much exit return या तुम्हारे stock ने कितना ज़्यादा return दिया है as compared to market. This is basically for the exit return, this function of intercept. If you want to know how much exit return or how much more return your stock has given, that is stock A, as compared to the market returns. अब return ज़्यादा भी दे सकता है, same भी दे सकता है, कम भी दे सकता है. Okay, but that you will find out by the value of the intercept. Okay, so now it says known y and known x. Again, you people can select the returns. We have the shortcut control shift down key, comma. You can go here to these returns, control shift down key. It means it has outperformed by 16% over the time period. This was your intercept. Okay, so that was one thing. So the intercept shows you the exit return that you have got. Up now, when we talk about this exit return particularly, this can be the return over the risk-free rate. If you are taking into consideration the market rate of return, your RF is the risk-free rate. And what do we mean by the risk-free rate? It is the rate of return on the government securities which cannot default, because ultimately the government backed hoti hai and the government won't default on their payments. Okay, that is the risk-free rate. So iske exist में market जो return दे रही है, that is our intercept. In case of the stock and market returns, आपका stock कितना ज़्यादा return दे रहा है as compared to the market. जो आपका stock है कितना return दे रहा है as compared to market. अगर ज़्यादा return दे रहा है, this value would be positive. It means your stock is giving you like more returns as compared to market. अगर कम return दे रहा है, this value would be negative. It means the stock is giving you like less return as compared to market. Okay. In the next session, we'll talk about how to calculate the cost of equity by using the CAPM model, like one of the most important models in the portfolio.